Alright, this video covers section 9.5 geometric series. So a geometric series is a geometric sequence with addition signs inserted into it. So you're going to add up the series, or add up the sequence in what's called a series. So 2, 4, 8, 16, 32, 64 is a sequence, but when you added the addition signs to it, then it's a series. This is a finite series because it stops instead of being infinite. Technically, you could just add these numbers together, but there's a formula for the finite geometric series. So, you need to know the number of terms, and sometimes that's the hardest part, is how many terms are there? Well, literally, we can just count them here. 1, 2, 3, 4, 5, 6 terms. So, S6 would equal A1, which is the first term, 2, 1 minus the common ratio. Well, the common ratio is the number that's multiplying every time, and that's just 2 here. And if you can't figure it out, 64 divided by 32 is 2. 32 divided by 16 is 2. You just divide the numbers next to each other, the bigger one, or the one on the right divided by the one on the left, and it's 2 every time. And then 6th power, and then 1 minus 2. So 2 to the 6th power is 64. 1 minus 64 is 63, negative. So it's 2 times negative 63 over negative 1. 2 times 63 would be negative 126 divided by negative 1, which is 126. So to prove to you that this actually is the answer, let's go ahead and add these numbers together. 2 plus 4 plus 8 plus 16 plus 32 plus 64. Boom. 126. So it worked. Now you'd want to definitely use the formula if it was a big, long series, but for something simple like this, you could just add it up. But it's also this formula, which is first term 1 minus the common ratio to the nth power, and then 1 minus the common ratio. Follow the order of operations, and you get 126. The next kind of series there can be, instead of finite, is infinite. And this right here is the formula for the infinite series that converges. So I'll draw a line across here. So if you have the infinite series that converges, you use this formula. The divergent series you can't do anything with. So if you have 3 plus 9 plus 27 plus 81 plus ... this is a divergent series. So the divergent series, the numbers just keep getting bigger and bigger and bigger, and you can't really do anything with it because the total you'll never find. So divergent, the series, the numbers just keep getting bigger and bigger and bigger and bigger. Convergent is this, the numbers are working towards something. So it's like they're narrowing in versus spreading apart. The common ratio here is 3. So the rule is if you have any common ratio greater than or equal to 1 absolute value, because common ratio can be negative, then that means that it diverges. So this means that if your common ratio absolute value is less than 1, then you're multiplying by a fraction, which means things are going to be getting smaller and smaller and smaller. So my example for this is 1/4 plus 1/16 plus 1/64 plus 1 over 256 plus ... So you can see the fractions are heading towards 0 because they keep getting 1 over a bigger number. So it's heading towards 0, so it converges. The common ratio is 1/4. I'm multiplying by a fourth each time to generate the next term. So I just use this simple formula here, which is actually related to the formula on the first page. So S, the sum, is equal to, first term, 1/4, divided by 1 minus the common ratio is 1/4. And by the way, I already know the answer to this is 1/3 based on the video that I did a couple of videos ago, where I took a box and I made it a fourth, and then I did a fourth of that, and then a fourth of that, and you can see that as you did a fourth all the way through, that it was 1/3 of the box. And so that was on a previous video. Following the order of operations, I'm going to subtract these two, and I get 3/4. When you divide, right, I'm dividing two fractions, I'm going to flip and multiply. So this would be 4's cancel 1/3. So it really is 1/3. So if you have a convergent geometric series, you can find the answer with this formula. If you have a divergent geometric series, you can't find the answer. And if you have a finite geometric series, you use this formula. So there's two new formulas today, one for finite and one for infinite that converges.